Hi everyone. For those who don't know me, my name is Yasemin Vardar. I'm an assistant professor at the Cognitive Robotics Department. Today we have approximately 30 minutes where I will introduce you tactile interfaces for human-robot interaction and human tactile sensation. The first 25 minutes of this lecture is recorded, but at the end, for 5 minutes, we will have a live question and answer session so that you can ask any questions that you want. Before I start my lecture, I would like to say that I hope you had a wonderful winter break and now you are full of energy for the new semester. And I hope 2021 brings joy, happiness, and health to all of you. So let's first start with a recap of touch sense. As you know, in all of our physical interactions that we do in our daily lives, we use our touch sense. Our touch sense has two components. The first one is the kinesthetic, which is sensing via our muscles and joints, which stems from body movement. And with our kinesthetic sense, we can perceive position, orientation, and forces. The second component is the tactile or cutaneous one, which is sensing via our skin. It stems from the skin contact, and via our tactile sense, we can perceive contact location, pressure, shear, slip, vibration, and temperature. And in this lecture, I will only focus on the tactile part. And I hope when I finish this lecture, you will have learned what is a tactile interface and what are the types of tactile interfaces, how tactile interfaces help us to interact with robots or machines, what are the design considerations for tactile interfaces, the general tactile sensation process, and skin receptors and their properties. So let's start with the definition of a tactile interface. According to Katrin Kuchenbecker, who is a well-known haptic scientist, a tactile interface is a device which senses a physical quantity from the user, for example, motion or force. It physically acts on the user's skin via a variable actuator, and it connects sensing to acting with fast processing. So if you would like to have a tactile interface, you have to combine all these three components. For example, if you have a device which cannot sense but only acts, it's not a tactile interface anymore, it is just an actuator. Or if you have a device which can sense but it cannot act, which means that this device is just a sensor, it's not a tactile interface. Over the years, there are hundreds of different tactile interfaces that has been built by research labs or companies. Unfortunately, we don't have enough time to mention all the tactile interfaces that has been built. But today I will briefly mention the different types of tactile interfaces so that you will have a broad perspective of these devices. The first type is the variable tactile interfaces. These devices directly mount on the skin of the user. For example, they can be fingertips, whole hand, or arm, or there are even whole body variable tactile interfaces. And depending on the actuator type that you are using, they can deliver you a vibration, skin deformation, pressure, contact, or temperature information. And unfortunately, we don't have enough time to cover all the actuators and sensors that can be used for different tactile interfaces, but hopefully you will learn those things in the next semester. The second tactile interfaces are surface ones. These devices can deliver tactile cues to the users using a flat surface, which is actuated by either electrostatic forces or mechanical vibrations. The third type is the pin arrays. Pin arrays are similar to surface tactile interfaces, but different from them, the tactile cues are delivered via the vertical movement of pins, which are placed in a 2D array. And depending on how you move these pins, you can deliver spatiotemporal skin deformations to the user. The fourth type is the mid-air tactile interfaces. For these devices, users do not have direct contact with the interface, but their skin can be actuated via focus ultrasound waves. And depending on how you change this focus, you can deliver different kind of sensations. And finally, there are tool-based tactile interfaces. As the name suggests, they deliver the tactile sensations via a tool, for example, a pen. And depending on the actuator that you choose, they can deliver you vibration, friction, or skin stretch sensations. So as you can see, there are different types of tactile interfaces, and depending on your application, you can choose any of these devices and can use them. But how can tactile interfaces help us to interact with robots or machines? The first thing that comes to people's minds about interaction between a tactile interface and a robot is teleoperation. Teleoperation, probably you already know, is remotely controlling a robot or a machine. For example, here there is a surgeon who does a minimally invasive surgery to a to a patient using a Da Vinci robot, and in the commercial parts of these robots, they don't deliver haptic cues to the surgeons. There is a leader side where the surgeon controls some tools by using their own visual cues, and they control the robot in the follower side. However, in this case, these scientists build a variable tactile interface that can deliver vibration, skin deformation, and contact information to the surgeon, which is kind of sensed from a sensor which is placed on the follower side. And during a palpation task, this sensor can sense the deformations or vibrations that occur on the skin of the patient, and this information directly transmit to the user using this variable tactile interface. With a similar logic, in this example, scientists put an accelerometer on the dental tool, and they recorded the vibrations that occurs between the dental tool and a tooth. And probably you all heard this annoying sound when a dentist moves this dental tooth on your teeth. Actually, this sound is caused by this interaction between tool and your tooth. And if your tooth is healthy or unhealthy, these vibrations are different, and dentists know that. So in this paper, they transmitted these vibrations via this tool-based tactile interface to the dental students so that they can learn the difference between a healthy tooth and unhealthy tooth. In this example, this user teleoperates a drone using a variable tactile interface. The drone has proximity sensors to sense the obstacles that comes to the drone. And depending on the distance between the obstacle and the drone itself, this glove can deliver vibration cues to the user. So if the obstacles are very close, there is a very large vibration feedback to the user. And if the obstacles are far away, the intensity is also lower. In this example, this user controls the robot for a pick and place application. This robot has pressure sensors and also accelerometer to sense the vibrations that occurs when the robot picks a glass, for example. And in this case, this user feels the vibrations and the contact forces that occurs when the robot picks a glass via this variable tactile interface. Also, we can use tactile interfaces to communicate with robots or machines. For example, here, the two robots follow a leader. These two robots have cameras that can sense the environment, and depending on the path that is most suitable for the leader-follower task, they warn their leader via this variable tactile device. In this example, this is a refreshable braille interface that can deliver tactile cues to the blind users so that they can interact with electronic devices. In this case, there is an autonomous car who warns the driver to hand over the control of the car. Also, we can use these tactile interfaces to enhance the user experience with the machines. For example, in this case, this tablet has a surface tactile interface which can deliver a texture of different materials to the users so they can feel much more interactive with the device. In this case, this user wears a wearable tactile interface which can deliver uh, button click effects so that when the user click virtual buttons on a VR environment, they sense it as if they were real. Here, this tool-based tactile interface can deliver tactile senses to the user as if the person is touching a pen and paper to make this drawing experience much more interactive. For this case, this game console can help help you to feel a much more interactive gaming experience. And for this case, this variable interface can give different kind of tactile cues so that you can feel AR or VR environments in a much more interactive or immersive way. So I hope with all of these examples, I could convince you that tactile interfaces can help us to interact with robots or machines. So I would like to design a tactile interface, but what should I know to do that? For that, we have to see again the definition of a tactile interface. As I told you before, tactile interface senses a physical quantity from the user, physically acts on the user's skin via a variable actuator, and it connects sensing to acting with fast processing. So depending on this definition, we can draw this schematic. Here we have this tactile interface which has sensors, actuators, and processors that communicates with these sensors and actuators, and also communicates with a virtual or remote environment which is connected to a robot or machine. And these sensors and actuators directly in a communication with the user's skin, depending on this skin deformations, this person can perceive different kind of tactile sensations. So from this definition and also from this schematic, we can say that design considerations of the tactile interfaces are human skin, human tactile sense, sensing, actuation, control, and electromechanical design. So let's say that you design a device which kind of actuates the skin, but this actuation cannot be sensed by the human. Your device is just waste of time and money, right? Also, for this tactile interface, you need to use sensors and actuators, and you have to know how to control them. And at the same time, you need to make a good electromechanical design so that your device can act as the way that you want for the specific application that you would like to use it. In this lecture, unfortunately, we don't have time to cover all these design considerations. I will mostly focus on the human skin and human tactiles.